So we're going to be doing problem 12-19 from the fundamentals of chapter 12. And at this point, they think, or the book thinks, that they can trick us, right? But we already conquered these problems, right? So we are given the position function in the y direction with respect to x, and then we're given the position function of x, or in the x direction, right? In terms of time. So right away we know that we can turn the position function in the y direction and write it in terms of time, right? Because we're just going to substitute the x equation into here, right? So t2 squared, and I froze, t2 squared, right? Which ultimately becomes, so that's 1/4, so that's pretty much 0.5. All right, sorry, I'm not squaring my terms correctly. This is t2 squared. Almost missed that. So that's 1/4 times 4 t to the 4th. So that becomes just t to the 4th. Okay, and then I know I need my velocity and acceleration in the y direction and the x direction. So let's just calculate that right away. Take one time derivative of the y position. So that's 4 t cubed, one more derivative, 12 t squared. All right, in the x direction, let's do that. 2t squared, one time derivative, we get 4t, and one more time derivative, we get 4. Okay, so right here we have all our equations that we're going to need in order to calculate the particle's velocity and acceleration when t equals 2 seconds. So let's do Vx at 2 seconds and Vy at 2 seconds. Okay. So let's just plug in 2 wherever you see a t, right? So we have, in the x direction, we have 4 times 2, and that's 8. Whoa. Meters. I have so many stuff uploading right now, so it's super slow. Okay, so we get 8 meters per second in the x direction, and now we have 4 cubed. Okay, and that'll give us, that's 8 times 4, 32 meters per second. All right, so we have one part of the puzzle right here. And I'll do the same thing in the x and the y for the acceleration. So ax is constant, 4 meters per second squared, right? So that one's pretty easy. We don't have to calculate anything. And then ay at 2 seconds, that'll be 12 times 2 squared, right? Which is 48 meters per second squared. Swoop, swoop. All right, let's switch colors. All right, so now we have velocity in the x and y direction, acceleration in the x and y direction. We get our component to our magnitude. We have 8 squared plus 32 squared. Okay. We get let's just say we get roughly 33 meters per second, right? And for the acceleration term, right here is, you're just cruising at this point. 4 squared plus 48 squared, right? And we get roughly 48.2 meters per second squared. Okay, and yeah, so that's it. We've calculated the velocity and acceleration magnitude at time equals 2 seconds. All right, you know, these type of things, try to plot them out on a graphing calculator. That way you can kind of start visualizing what's happening. All right, like I did in the previous videos. But yeah, hope this video helps. I know this problem, this problem is, hopefully it's easier for you guys at this point, just because you've already done quite a few of these. And yeah, if you have questions, comments, concerns, just comment down below, and don't forget to like and subscribe. Thanks guys, I'll see you in the next video.